So how do we find the molecular mass of calcium hydrogen sulfite? Well, let's use this table to help us organize our thoughts. Bam! So the first thing I'm going to do is write down the elements in the compound. So we have calcium, we have hydrogen, we have sulfur, and we have oxygen. Next is to write then the number of atoms of each. So for calcium, the subscript there is a 1. That means we have 1 calcium atom. For hydrogen now, the subscript is a 1, but hydrogen is part of the hydrogen sulfite polyatomic anion, and you have 2 of them. So if in each one of these polyatomic anions there's 1 hydrogen, but then you have 2 polyatomic ions, right? That would mean that there are 2 hydrogen. In other words, you take the subscript of hydrogen and simply multiply it by then that subscript on the outer side, all right? So same thing for sulfur. Sulfur is a 1, but then we have 2 of those polyatomics, so we'd have 2 sulfurs in total. We're multiplying, and then 3 oxygen in here, but then you got to take the 3 and multiply it by the 2, so that's 6 oxygen. Then what we're going to do is we're going to multiply those number of atoms of each by the mass of each particular element. Where do we find the masses of elements? You got it, periodic table. So let's take a look. Here is calcium, that's the mass. Now that mass could be represented as gram per mole or AMU, depending upon if you're calculating molar mass or molecular mass. So we have this 40.08 for calcium, 1.01 for hydrogen, 16 for oxygen, and 32.07 for sulfur. So let's write it down, right? Calcium was 40.08, hydrogen was 1.01, sulfur was now 32, right? 32.07, and then oxygen here was going to be 16. All right, and then to find now the total mass of the element in the compound, we're simply going to then multiply now this row together. So 40.08 times 1 is obviously 40.08, right? 1.01 times 2 is going to be 2.02, right? 2 times then the mass of sulfur here, 32.07, is going to work out to be 64.14. And then you got 6 oxygens, so just take that and multiply by the mass of each oxygen. So that's going to be 96 in total. Okay, you can add in the zeros there if you want. It really doesn't make a difference, obviously. And then to find now the total mass of the entire compound, all we're simply going to do is add this column up. So when we add that column together, we get a total mass of roughly 202.24. And since we're calculating molecular mass, the units here are in AMUs, aka atomic mass units. Guys, thanks so very much for tuning in. I really do appreciate it. Help us out by subscribing and liking, maybe even telling your friends. We got thousands of videos out there for you, solved solutions just to help you through your class. All right, check it out. We got a whole bunch of subjects, not only chemistry here, but physics, mathematics. We got a whole bunch of other stuff coming out. Thank you so very much. See you then.